Hi everyone. Today we'll solve a related rates problem involving a rocket. A camera is recording a rocket launch. Here is our camera. Here is our rocket. The camera is 5,000 feet from the launch spot. This means that this distance is 5,000 feet. As the rocket goes up, the camera continuously changes the angle that it uses to record the rocket. The camera is recording the rocket, which creates an angle that I will call theta. We must find the rate of change of the camera angle as a function of time when the rocket is 1,000 feet from the ground. Because this is a general picture applicable to all moments in time, I will not add 1,000 here because that distance changes over time. I will give it a name. I will call it by h. And I know that I will be interested in some rate, in fact, in the rate of change of theta whenever h is 1,000. We are told that the velocity of the rocket at the moment of interest is 600 feet per second. This means that the rate of change of h with respect to time at that moment is 600 feet per second. Let's write that down. We know that the derivative of h with respect to time whenever the rocket is 1,000 feet from the ground, whenever h is 1,000 feet, is 600 feet per second. But I will suppress the units for now. I am interested in how fast the angle is changing at that moment. I am interested in d theta dt whenever h is 1,000. I know one rate at a particular moment. I want to know a different rate at a particular moment. H and theta are related. The bigger h, the bigger theta. The smaller h, the smaller theta. Their rates are also related. Can we find an equation that relates h and theta? We can use trigonometry. H divided by 5,000 gives me the tangent of theta. The equation is h divided by 5,000 equals tangent of theta. This is the same thing as 1 over 5,000 times h equals tangent of theta. I rewrote it this way so that it's easier for me now to introduce derivatives. I will take the derivative on both sides of this equation with respect to time. On the left side, I have a number times a function. Remember, h changes over time. That's why I gave it a letter in the picture and I didn't name it by 1,000. Similarly, theta is a function of time. So both h and theta are functions. When I take the derivative on the left side, I use the constant multiple rule. I rewrite the number and then I take the derivative of h and I get dh dt. On the right side, I take the derivative of tangent of theta. I use the chain rule. The derivative of the inside function, the derivative of theta is d theta dt. The derivative of tangent is secant squared of theta. My goal is to find d theta dt, so let me divide both sides by secant squared. And that gives me d theta dt is equal to the left side, 1 over 5,000 dh dt, divided by secant squared of theta. I am interested in the rate of theta with respect to t whenever h was 1000. This allows me to plug in dh dt given to me in the problem. dh dt whenever h is 1000 is 600. So instead of writing dh dt here, I can write 600. What can I write instead of secant squared of theta? Theta was not given to me, which means I am not sure what secant of theta is, and I am not sure what secant squared of theta is. Thankfully, whenever h is 1000, I can compute what theta is, which means I can compute what secant is, which means I can compute what secant squared is. Let's draw a picture at a particular moment whenever h is 1000. 5000 at the bottom never changes. 1000 on the right side is at the particular moment when the rocket is 1000 feet above the ground. I am interested in secant of theta. To know what secant of theta is, I know that secant is the same thing as 1 over cosine. Cosine of theta is this side divided by this side, which means that secant is this side divided by this side. To compute secant, I need to first compute the length of this side by the Pythagorean theorem. If I call this side by the letter c, by using Pythagorean theorem, I know that c squared equals 5000 squared plus 1000 squared. This means that c equals the square root of that expression, 5000 squared plus 1000 squared. I used the calculator to simplify this expression, and I got 1000 square root of 26. Because c is 1000 square root of 26, and secant is this side divided by this side, at that moment in time, secant of theta will be 1000 square root of 26 divided by 5000. This gives you, if you cancel the zeros, this gives you square root of 26 divided by 5, which means that secant squared of theta is 26 divided by 25. I simply squared the numerator and the denominator. Now I know all the expressions in my equation on the right side. I get 1 over 5000 times, instead of dh dt, I can plug in 600, and instead of secant squared of theta, I can plug in 26 divided by 25. Let's simplify this. Dividing by 26 over 25 is the same thing as multiplying by 25 over 26, multiplying by the reciprocal. What's more, a few zeros here cancel, which gives me 6 over 50 times 25 over 26. I can now simplify 25 and 50, that gives me 1, that gives me 2, and I can also simplify 6 and 2. That gives me 3, that gives me 1. So I get 3 over 26. The angle was measured in radians. The time was in seconds. So the units are radians per second.